Hello, my name is Steve. I'm an application engineer at XenomatiX, and today I will demonstrate how to process and visualize the data captured by the XenoTrack. So let's get started. Usually when you capture data with the XenoTrack, you will capture everything in a project, and then you will see here all the sessions that were captured. If I open one of the sessions, we can see that we have different folders. So we will have camera images, we'll have GPS data, we'll have raw point clouds of the LiDAR. What does a raw point cloud of the LiDAR look like? It looks like this. So it's a point cloud of around 2 meter long on a bit more than 4 meter wide. It's not really rectangle, but mostly trapezoidal. And there are like 28,000 points in this point cloud that give like a really accurate image of the road. So how to process then all this data to make it like one nice long point cloud and give all the outputs that we want. This is what we will see now. So for that we have a software called Digital Road Plus. So it's really simple to use. You just select the data set you want to select. So I will go and select my project, and then I do select folder. The software will scan for valid sessions, so it will basically look what are the folders that contain valid data. And then, you find all the sessions in my project. You can see that most of the sessions are still gray, but one is green because it was already processed, and so it indicates that there was some successful steps. So afterward, you can select which session you want to process, so either one by one, or select them all, or unselect the one that are already processed that you can choose. And then you have some outputs that you can choose to choose which one to generate. So you have the height and intensity maps that are basically the basic of our software. You will always want to generate them. You have height and intensity automap images, which are more like pictures of the stitching of the different frames. You have height profiles, which are like the raw profiles on which you can do IRI computation, for example. You have LAS and CRG formats, which are point cloud formats. You have IRI, which is the International Roughness Index. So we'll give a qualitative index of the road. You have fretting. You have waviness, which is the Belgium standard for evenness. You have the macro texture with the MPD computation. You can geotag the camera images. You can detect the potholes, detect the cracks, do some PCI estimation. So all this in the software. And then you have some parameters that you can set. So for example, the resolution of the map you want to create. You always want to find the correct trade-off between how much points you get, so higher resolution, and how much data you want to generate. The higher the resolution, the more data you will get. And then you can choose, for example, also the width of the road. So if you want to process the road of only 2 meters because it's a small back lane, or 8 meters because you measure 2 lanes with a dual lane, that's up to you. You also have some advanced settings, for example, to choose what should be the block length of the RI value, what should be the segment length for the pothole detection to report it. So you have a lot of parameters that you can set, and so it's really a lot up to you to configure it with how you want to process the data. And then once you select everything, you can just hit process selected session, and then it will start processing the session. So here we'll see it started with the first session, and now it's doing the first step of the processing, which is loading the data, or the LiDAR data basically. And so it will run every session until it's reached the end. So that's basically how it will work. So now we see finish the first step, so this turns green. it will go all the way until it finishes every steps. So after we finish this processing, this can run overnight, or like you don't need to be there to see how it runs. And afterwards, so I said that there was one session already processed. So we can take a look. We'll have this log folder, and inside we'll see there are different files that are generated. And so you have files that are like more indexes, like routing, for example. And I will open one of those files. So this is like CSV format, so it's easily readable by office tools like Excel, for example. And then you will have different columns. You will have the left value for the routing, the right value, the average depth. You will have a column also called geometry, which is give basically what the segment is computed so that you can import it in QGIS or other GIS softwares. And so this is how the routing will work. So then we have the same for, or we can generate the same for like potholes. So you'll have the segment index, or where is your pothole detected. The distress type, the severity, the area of the pothole, the volume it occupies, the depth, the average and max depth, the position, so all this information. Same goes for the cracks. So again, you have where you have the cracks, the type of crack, the severity, the area, the length, the width, the position. So all this in this CSV file. You can then also have for the PCI estimation, so you give a segment length, and then for each segment you get a value, and then if it's good or not, and the position of this segment. And then you also have like shape files for the potholes and for the cracks. And so all this data is meant to be read easily by like office software, like Excel, for example, so using CSV format, but also by GIS software. And so, if I take an example in QGIS, for example, so I told you that we can easily import everything in GIS software. So, I will demonstrate that. So, for example, we have the last file. We can just drag and drop it. It will appear like this. So the last file is really like the point cloud, let's say. If we really zoom in, we can see it's all made of different points. And we basically also give a color code based on height. So everything green will be what is lower or the mean plane. Everything blue or purple will be what is lower than the mean plane. And then everything red or yellow that for example, we can see here is what is higher than the mean plane. And based on that, we can see subsidence, we can see curbstones, we can basically have a better idea of the geometry of the road. This file also contains like intensity. So if I change it, then we see the intensity. So this is still LiDAR data, just how reflective the ground is, and this will give us a grayscale image of the road. We can then see like patches and big cracks and different underground. For example, here we can see that it's some small stones. So that's it. We can also import like the CSV files, like I said. So if I take, for example, here my file, I will open it. And then this other column. And once I will add it, I can then, so we'll see that a line will be drawn to show routing, and then I can add a style, for example. So let's add my routing style, for example. And then we can see the parts are more or less routing. So green means that it's good, red that is not that great. So this color scale can also be adapted by yourself. So really you can see on the map the data. So this can be done also for RI, PCI, yeah, cracks maybe. So yeah, you can also have also shapefile for cracks, for example. Again, a shapefile can just be drag and drop. My computer allows it, yeah. Okay, and then we have yeah, the shapefile is all the cracks that are appearing, and yeah, this can be done for all the data. So I already made a project. Yeah, here we can see we have all our outputs, and so for example, I can now put the cracks on, so we can really see there is a mask with all the cracks. And so if I zoom in, yeah, we'll see that, for example, here we have a nice area without cracks. So if I add the pictures, yeah, maybe I have to, you can see indeed there is a patch. We'll see all the cracks around it. We'll see that here there is a whole area without cracks, and here also in the middle of the road, which can also be seen here. So really it will detect all the cracks. Now we can also check what exactly was detected. So this is picture 9. If I go to picture 9 in my crack detection file, I can see what is actually detected. So we'll see all the cracks here are detected. Here we have this area without detection. Here another cracking is detected. Some cracks on top are detected. So that is what is actually detected by the AI. For all those cracks, we also have like the severity, the average width of the opening. So if I check a bit, for example, this mask, then we can see we have an average width, an ID for the crack, a severity, the type of crack. Yeah, so that's it. We then also have like the pothole detection. So I will put the pothole mask, and now we'll check. So we have several potholes that are detected on this road. If I zoom in on the pothole, we can see that basically the shape will go around the shape of that you can see in the height map. If I take a look at the pictures, yeah, we can really see that there is a nice pothole here. And so again, for this pothole, we have yeah, the average depth, the maximum depth, the area, the volume, the severity, its ID. So you really have all the information about this pothole. And then, like I said, there are some indexes. For example, RI or routing. So if I put RI, I will plot it with a line on the ground. So we'll remove the pictures and the potholes. And then we can see, okay, the RI on this road is not that great. It's mainly black. So here is the color scale I used. So mainly black means an RI higher than 10. in the wheel tracks. Some parts are a bit better than others. And it's also because it's not a great road. And then you have now you have IRI, so you have two values of IRI. So for the left and right track, you have three values, and then also the center track, but those tracks can be adapted. So you can also decide, I want 10 values of IRI every, for example, 25 centimeters or something like this. So that's up to you. And then you also have the worst IRI value that is reported, and that's the one that is plotted now. And then in the same way you have rutting. So rutting is also reported by segment, and you can also colorize it. So here you see the color scale I chose, just to get an idea of where is actually a lot of rutting. Maybe for rutting, it could be interesting that I take another example. So here I again have my project where I put my last file. If I zoom in, I will really see some nice wheel tracks that are in blue. So yeah, you can really see the nice wheel tracks in blue. And so if I put my rutting, I will see that there is a black value because the value is really high there. I have some other places where it's green. Yeah, indeed we don't see those wheel tracks. Again, I can look a bit at the information that is inside. So if I look at the information that there's inside, for example, in this segment, I can see, the left and right values of rutting are really high, almost 3 centimeters of rutting. That's really important. So yeah, that's for rutting. So if I come back to my other data set, like I said, we have the pictures that will be, geotagged on the road. So every 3.5 meter we'll have a picture. And so that's basically the data you can visualize in a GIS software. So that was the overview of what you can have with the XenoTrack. I hope you enjoyed and you had a nice overview, and thank you for listening to me.